Ethereum's foundation lies in Vitalik Buterin's white paper, outlining its core concepts. A central idea is the world computer, envisioning a decentralized computing infrastructure. This world computer aims to revolutionize digital interactions through blockchain technology. It promises to create a more open, secure, and efficient digital landscape. The 2014 presale event successfully raised $18.3 million. This funding was exchanged for 60 million Ether, the native cryptocurrency of Ethereum. Animated graphs will illustrate the initial distribution of these ETH tokens. The visualization will also represent the initial value of ETH at the time of the presale. Ethereum's Frontier was launched on the 30th of July 2015. A key feature of Frontier was its block gas limit, set at 5 million. This gas limit enabled the deployment and execution of smart contracts on the Ethereum blockchain. Smart contracts are self-executing agreements written in code. The launch of Frontier and its smart contract capabilities opened Ethereum to a broader community of developers. Smart contracts are self-executing agreements written in code and stored on a blockchain. The deployment process begins with writing the smart contract code, typically in Solidity. After coding, the contract is compiled into bytecode, which is understandable by the Ethereum virtual machine, EVM. The compiled bytecode is then deployed to the Ethereum blockchain via a transaction. This deployment transaction incurs a cost, known as gas, which compensates miners for processing the transaction. Once deployed, the smart contract's code is immutable, and its functions can be invoked by users or other contracts. In 2016, the DAO, a decentralized autonomous organization, suffered a critical security breach. Hackers exploited vulnerabilities within the DAO's smart contracts. This exploit led to the unauthorized draining of approximately $50 million in Ether. The attack highlighted the risks associated with unaudited and complex smart contract code. The Ethereum community debated rolling back the blockchain's history following the DAO hack. The DAO hack involved a significant exploit of a decentralized autonomous organization. The rollback proposal aimed to reverse the effects of the hack by altering the blockchain. This proposal caused a major division within the Ethereum community. The community ultimately split, leading to the creation of two separate blockchains. These two blockchains are now known as Ethereum, ETH, and Ethereum Classic, ETC. The DAO hack prompted significant changes in Ethereum's governance. Early governance relied heavily on core developers' decisions. Later models incorporated community input through voting and discussions. These structural changes aim to enhance network resilience and decentralization. The ERC-20 standard is a technical standard for tokens on the Ethereum blockchain. It defines a common set of rules that all Ethereum tokens must follow. This standardization enabled developers to easily create and deploy new tokens. The ERC-20 standard played a crucial role in the 2017 ICO boom. It facilitated the creation of hundreds of new tokens, driving significant investment and innovation in the crypto space. The year 2017 saw a rapid increase in initial coin offerings, ICOs. Animated charts and graphs effectively represent the capital influx during this period. These visualizations also highlight the proliferation of new ICO projects. The rapid growth can be illustrated through rising trend lines and expanding data points. Visual representations provide a clear understanding of the ICO market's expansion in 2017. CryptoKitties is a blockchain-based virtual game centered around collectible and breedable digital cats. The game's popularity led to a surge in transactions on the Ethereum network. This sudden increase in activity caused significant network congestion. As a result, users experienced slower transaction processing times. The increased demand also drove up gas fees, the cost to execute transactions on Ethereum. NFTs, or non-fungible tokens, are unique digital assets representing ownership of items. Unlike cryptocurrencies, each NFT is distinct and cannot be directly exchanged for another. NFTs utilize blockchain technology to ensure verifiable scarcity and authenticity. They have gained prominence in the digital collectibles market, representing art, music, and virtual items. NFTs enable creators to monetize their digital work and provide collectors with proof of ownership. The 2018 crypto winter significantly impacted the Ethereum ecosystem. A major effect was the substantial decline in cryptocurrency prices, including Ether. This price drop led to a decrease in speculative trading and investment activity. Reduced speculative activity resulted in lower transaction volumes on the Ethereum network. Overall, the crypto winter presented challenges for Ethereum's growth and adoption. During the crypto winter, DeFi developers concentrated on building essential infrastructure. The focus was on creating robust foundations for future DeFi applications. This period emphasized the importance of fundamental protocol development. Developers aimed to enhance the resilience and scalability of DeFi systems. The proof-of-stake (POS) merge represents a significant transition in consensus mechanisms. It shifts the validation process from proof-of-work (POW) to proof-of-stake (POS). This transition substantially reduces energy consumption, achieving a 99% reduction. POS offers a more energy-efficient and environmentally sustainable approach to blockchain consensus. Rollups are Layer 2 scaling solutions designed to enhance Ethereum's transaction throughput. They primarily function by executing transactions off the main Ethereum chain. After execution, transaction data is then posted to the main chain in a compressed form. This process significantly reduces the computational load on the main Ethereum network. Consequently, transaction costs are lowered, making Ethereum more accessible. Rollups effectively increase the number of transactions that Ethereum can process per second. Blob transactions are implemented to enhance scalability on the Ethereum network. A primary goal of blob transactions is to reduce gas fees for users. Blobs represent a new type of data storage, distinct from traditional Ethereum transactions. Traditional transactions store data directly on the blockchain, increasing its size and cost. Blobs, conversely, store large amounts of data off-chain, reducing congestion. This off-chain storage contributes to lower gas fees and improved transaction processing speeds. Regulatory clarity fosters a more secure and predictable environment for Ethereum. This clarity encourages institutional investors to enter the Ethereum ecosystem. Increased institutional capital fuels further development and innovation on the Ethereum platform. Regulatory certainty can lead to greater adoption of Ethereum-based solutions across various industries. Clear regulations help to legitimize Ethereum, enhancing its long-term viability and growth potential. Stablecoins, such as USDC and PayPal USD, are integral to decentralized finance, DeFi. They facilitate transactions within DeFi ecosystems by providing a stable value reference. Stablecoins mitigate the price volatility typically associated with other cryptocurrencies. Their stability enhances the reliability and usability of DeFi applications. DeFi lending protocols enable users to borrow and lend digital assets in a decentralized manner. These protocols operate on blockchains like Ethereum, utilizing smart contracts to automate lending terms. Lenders deposit their digital assets into a lending pool within the smart contract. Borrowers can then take out loans from these pools by providing collateral. Smart contracts automatically manage interest rates, collateralization ratios, and loan liquidations. This system removes intermediaries, offering potentially higher yields for lenders and more accessible loans for borrowers. NFT minting is the process of converting digital assets into unique tokens on a blockchain. This process tokenizes assets, representing them as NFTs on the Ethereum blockchain. The digital assets' information and ownership are permanently recorded on the blockchain's ledger. Minting involves creating a new block that contains the NFT's metadata and links it to the asset. The newly minted NFT can then be bought, sold, or traded on NFT marketplaces. This process ensures the digital asset's authenticity and verifiable ownership. Individuals can participate in DAOs by acquiring and holding the DAO's governance tokens. Holding governance tokens typically grants voting rights on proposals affecting the DAO. Participants can propose changes to the DAO's rules, operations, or treasury management. Community members actively engage in discussions and debates surrounding proposed changes. Token holders vote to accept or reject proposals, directly influencing the DAO's direction. MetaMask serves as a bridge connecting users to Ethereum's decentralized applications dApps. Users can interact with dApps directly through the MetaMask wallet interface. MetaMask allows users to manage their Ethereum accounts and sign transactions securely. When a dApp requests a transaction, MetaMask prompts the user for confirmation. This process ensures users maintain control over their funds and interactions within the Ethereum ecosystem. Ledger hardware wallets are designed to securely store cryptocurrencies like Ethereum. These devices safeguard private keys offline, minimizing the risk of online theft. Ledger wallets require physical confirmation for transactions, preventing unauthorized access. They support multiple cryptocurrencies, offering a versatile security solution. The secure element chip enhances protection against hardware attacks. Coinbase Wallet enables users to engage with the Ethereum ecosystem. Users can securely buy Ethereum, ETH, and other Ethereum-based assets directly within the wallet. The wallet facilitates the selling of Ethereum assets, converting them back to other cryptocurrencies or fiat. Coinbase Wallet provides tools for managing a diverse portfolio of Ethereum-based tokens and NFTs. The wallet offers a user-friendly interface for tracking asset values and transaction history. DeFi lending dApps enable users to earn interest by lending out their cryptocurrency assets. Users can also borrow funds by providing collateral in the form of other crypto assets. These platforms operate using smart contracts, ensuring transparency and automation. Popular DeFi platforms offer various lending pools and borrowing options with different interest rates. NFT creation platforms provide artists with tools to tokenize their digital works. These platforms offer resources for minting, selling, and managing NFTs. Creators can utilize various platforms to showcase and monetize their digital assets. These platforms simplify the process of converting digital art into unique, tradable tokens. Blockchain technology is being integrated into gaming to enable new mechanics. One key feature is the implementation of play-to-earn models. Players can earn cryptocurrency or NFTs through gameplay. Blockchain also facilitates true digital asset ownership for in-game items. These assets can be traded or used across different games and platforms. DAOs utilize voting mechanisms to enable decentralized decision-making. Token holders in a DAO can participate in these voting processes. Each token typically represents a certain amount of voting power. Proposals are submitted to the DAO for consideration and voting. Token holders then vote on these proposals, using their tokens to cast their votes. The outcome of the vote determines whether the proposal is accepted or rejected, guiding the DAO's actions. Ethereum forums and Discord channels are key platforms for community engagement. These platforms provide avenues for asking questions and seeking clarifications. They also facilitate collaboration with other community members. Active participation enhances understanding and problem-solving within the Ethereum ecosystem. Minting a token on Ethereum involves creating a new digital asset on the blockchain. This process typically starts with writing a smart contract that defines the token's properties. The smart contract is then deployed to the Ethereum network, assigning it a unique address. Calling the mint function within the smart contract creates new tokens and assigns them to a specified address. This action permanently records the token's existence and ownership on the Ethereum blockchain. DAOs allow token holders to participate in decision-making processes. Token holders can vote on proposals to influence the direction of the project. Voting power is usually proportional to the amount of tokens held. This mechanism ensures community governance and project evolution. Sharing one's Ethereum journey involves documenting and communicating personal experiences with the Ethereum ecosystem. This includes sharing insights, challenges, and lessons learned while interacting with Ethereum technology. Contributing to the community's collective knowledge base is a key aspect. Sharing experiences helps others learn and navigate the Ethereum space more effectively. Ethereum provides a decentralized platform for building various business applications. Smart contracts, automate agreements and transactions, reducing the need for intermediaries. Decentralized finance. DeFi applications offer new financial services and opportunities. Tokenization allows businesses to create and manage digital assets on the blockchain. Scalability and security remain key challenges for businesses operating on Ethereum. Ethereum can be used to fund local causes through decentralized platforms. These platforms enable direct support for community initiatives. Decentralization ensures transparency and reduces intermediary involvement. This approach fosters community engagement and targeted financial support. Ethereum facilitates collaboration across international borders by leveraging its decentralized blockchain technology. Its global nature allows individuals and organizations from different countries to interact without intermediaries. The permissionless characteristic of Ethereum ensures that anyone can participate in the network. Smart contracts automate and enforce agreements, fostering trust among collaborators from diverse legal systems. This technology streamlines cross-border projects, reducing friction and enhancing transparency in international collaborations. Ethereum is a decentralized, open-source blockchain platform. It enables the creation of smart contracts and decentralized applications dApps. Key concepts include blockchain, cryptocurrency, Ether, and smart contracts. Resources for learning include online courses, documentation, and community forums. Ethereum transactions are initiated by users to transfer value or interact with smart contracts. Each transaction is broadcast to the Ethereum network, a decentralized peer-to-peer system. Miners validate these transactions by solving complex cryptographic puzzles. Once validated, transactions are grouped into blocks and added to the blockchain. The blockchain serves as a permanent, immutable record of all Ethereum transactions. Smart contracts and users interact on the Ethereum blockchain. These interactions can be visually represented through abstract animations. Animations help illustrate the flow of data and value between contracts and users. This representation simplifies understanding of complex smart contract operations. Ethereum is designed with an open architecture to promote accessibility. This open design fosters inclusivity for developers globally. It also ensures that users worldwide can easily access and utilize the platform. The open architecture facilitates innovation and collaboration within the Ethereum ecosystem. Ethereum has demonstrated a notable capacity to withstand and recover from various challenges. Its architecture allows for continuous adaptation and upgrades in response to emerging threats. The decentralized nature of Ethereum contributes to its robustness against single points of failure. This resilience ensures the ongoing functionality and security of applications built on the Ethereum blockchain. Ethereum's strength lies in its collaborative ecosystem. Developers contribute code and build decentralized applications. Researchers advance the underlying technology and protocols. Users provide feedback and drive adoption of the platform. This synergy fosters innovation and continuous improvement. The community-driven approach is vital to Ethereum's evolution. Ethereum is designed to foster an environment conducive to innovation and creativity. Its architecture allows developers to build and deploy decentralized applications dApps. Smart contracts automate agreements, reducing the need for intermediaries. This automation enhances efficiency and reduces transaction costs. Ethereum's open-source nature encourages collaboration and continuous improvement. The platform's flexibility supports a wide range of applications, from finance to gaming. Proof of work, POW, is a consensus mechanism used in early Ethereum. POW requires miners to solve complex computational problems. Solving these problems requires significant computational power and energy. This high energy consumption was a notable characteristic of early Ethereum's POW system. Proof of work, POW, and proof of stake, POS, are consensus mechanisms used in blockchain technology. POW requires significant computational power to solve complex cryptographic puzzles. This process, known as mining, consumes substantial amounts of energy. POS, on the other hand, selects validators based on the number of tokens they hold and are willing to stake. POS significantly reduces energy consumption compared to POW, as it eliminates the need for intensive computation. Ethereum blockchain incorporates advanced cryptographic techniques to ensure data integrity. Its decentralized nature makes it highly resistant to tampering and single points of failure. The consensus mechanisms in Ethereum, like proof of stake, enhance network security. These features collectively provide a robust defense against censorship and unauthorized modifications. Decentralized applications dApps operate on a decentralized network, like Ethereum. dApps encompass a variety of applications, including DeFi, NFTs, and gaming. DeFi dApps offer decentralized financial services, such as lending and trading. NFT dApps manage and trade unique digital assets, ensuring ownership and provenance. Gas fees on Ethereum are payments users make to compensate for the computing energy required to process and validate transactions. These fees ensure that miners or validators are incentivized to include transactions in the blockchain. Gas fees are denominated in Gwei, a small fraction of Ether, ETH, the native cryptocurrency of Ethereum. The amount of gas required for a transaction depends on its complexity and the computational resources it consumes. Higher gas fees typically result in faster transaction processing, as miners prioritize transactions with higher rewards. Ethereum network congestion occurs when transaction demand exceeds the network's capacity. Increased congestion leads to a bidding war for transaction inclusion in blocks. Users increase gas fees to incentivize miners to prioritize their transactions. Higher gas fees result from this competition, making transactions more expensive. Congestion also causes slower transaction confirmation times due to the backlog. Layer 2 solutions are designed to enhance the scalability of Ethereum. These solutions operate on top of the Ethereum mainnet to improve transaction throughput. Rollups are a prominent type of Layer 2 solution. Rollups alleviate network congestion by processing transactions off-chain. This off-chain processing subsequently reduces gas fees for users. Ethereum has significantly shaped the landscape of Web3 and decentralized technologies. It serves as a foundational platform for decentralized applications dApps. Ethereum introduced smart contracts, enabling automated and trustless agreements. It has fostered innovation in decentralized finance, DeFi, and NFTs. Ethereum's influence continues to drive the evolution of a more decentralized digital future.